Hey everyone, this is Reflection, and today we'll be doing some deep learning tasks which are classification, regression, and image classification, which I have already done, and I am doing these tasks on different data sets. So for classification, we'll be using the iris data set that is available in the sklearn data sets. We'll start with importing all the necessary files. We'll get NumPy, Pandas, TensorFlow, and we'll from TensorFlow we also will also import Keras and we'll train our model on Keras. First, we will use the encoder. We'll encode the labels. Then we'll split the data set. So the iris data set is pretty clean already. We'll split the data set into X train, X test, Y train, and Y test. We'll split it into 80 and 20%. Then we'll standardize the feature. We'll use that from using scalar.fit from Keras, and then we'll define the neural network. So we need um, a, a three-layer dense neural network with the activation function as well. And then we will compile the model, and then we'll just call the model.fit function. And this is what we got for our accuracy, which was 90% accuracy, and loss was zero point 0.3, and validation accuracy was 96%. We'll evaluate the model, and this is the test accuracy prediction. This is the ROC curve, and this is the precision recall curve. This was the training history plot, and this was the model loss throughout. This is how we were will model looking like. This was a basic classification task. Let's move on to the regression part. Here we have taken expectancy data from Kaggle. We'll start by understanding the data set. This is how our data set looks like. It has some missing values. We'll handle the missing values by dropping some values. We'll pre-process, then we do the categorical and encoding, and then we will be splitting the data set. We set the target variable, then we build the regression model. Then we start with the training of the neural network. At first, the loss was pretty high, and uh, it, at the end, we got a nice loss and MAE function. Our prediction were pretty good. This is a performance matrix. So ROC, R2, R square score, and the MAE and MSE values looks pretty good. This is the actual versus predicted plot of our neural network. And this is the visualization of model loss over epochs and model MAE over epochs. And these are our different metrics, the root mean square error, and other things. Let's go to image classification. Yeah, so we'll start with importing all the library, and we'll go to the fashion MNIST data set, which we'll be using. We got it from Kira's data set, and then we'll do the data preprocessing. It was a low model with lower resolution images, and we are now building a CNN. This is the configuration of our CNN, and then we train the model. We got a nice accuracy over here, and then we do have a classification report. This is the confusion matrix. It was a multi-class classification. Then we visualize the model accuracy over time, and analysis tells almost everything about the model. Thank you so much for watching. I hope you learned something out of this. Subscribe and like.